to work out for you number 43, parts A, B, and C from chapter 18. Follow the video until you get what you need to know, and then stop it and continue on until you get stuck again. You're not going to learn too much by just watching. So try it first and then watch it if you need something explained that you're not getting. Okay, so here's our circuit. We have a battery of 12 volts. We have 4 resistors. I've numbered them 1, 2, 3, and 4 so that I can keep track of which resistors I've combined together. We're supposed to find the equivalent resistance, current in the battery, and current in the 30 ohm resistor. I'm going to use a chart to help keep track of my work. I'm going to fill in the resistor values: 30 ohms, 50 ohms, 90 ohms, and 20 ohms. So the first step is to find the equivalent resistance. I need to look for something that is a pure series or a pure parallel combination. So these are not pure parallel because you can see the battery here. So the battery's in a little bit of a different place, but you can see that this one, the flow is going to all go through this resistor and then it's going to branch. So these two look like they're in series with each other. So I'm going to first combine those together. So the resistance of 1 and 2 together would be 30 ohms plus 50 ohms. We add resistors that are in series, so that's equivalent to 80 ohms. And I'm now going to redraw the circuit. I'll redraw it over here. So my circuit now is going to look like this. And resistors 1 and 2 I've combined now, to be equivalent to 80 ohms. This one is 90 and this one is 20. Okay, now I can see that we have one wire here and then it branches into 2 pathways, and then those 2 pathways recombine here, and this once again would be the total current. So these two look like they are in parallel now. So 1 over the resistance of, this would be 1, 2, and 3 combined, is 1 over 80 plus 1 over 90. So calculate that and you will find out that it is 42.4 ohms. But we're not done yet because we still have this resistor. So drawing the circuit yet again, now it would look like this. Okay, where this parallel combination has been replaced by an equivalent resistor with a value of 42.4 ohms. Now I have 2 resistors that are in series with each other. So when resistors are in series, you add them together, and this is going to be my total equivalent resistance because this is it for all the resistors. So 20 ohms plus 42.4 ohms equals 62.4 ohms for the equivalent resistance. Check, we did part A. Now they want to know the current in the battery. Well, let's see, we know the total pressure difference of the battery is 12 volts. So finding the current, total current coming out of the battery is going to be pretty straightforward. So the pressure difference or potential difference is the current times the resistance. 12 volts equals the current times the resistance. And calculating that, we find that the value is 0.19 amps. So now let's think about what this means. 0.19 amps is the total current flowing in the circuit. So that's the answer to part B. But also, it might tell me something else about something else in the circuit. So the total current is going to be flowing here because there have been no branches yet. It's going to be the current that flows through resistor 4, and then the current that continues on this way. So that's going to be the current through resistor 4, and I can fill that in over here, 0.19 amps. Okay, now let's see, we're supposed to be headed towards finding the current in the 30 ohm resistor. So we want to know the flow through this resistor up here. So I'm going to have to work my way up there to figure that out. So I know the flow right here. At this point, the flow is going to split into two branches. Some of it will flow this way and some of it will flow this way. And those two branches are going to add up to this one. But I don't know either one of those yet. So let's see, what could I find? Well, I could find the pressure difference or the potential difference for resistor 4. So let's go ahead and find that. So it's going to be the current times the resistance, and that comes out to 3.8 volts. Okay, so what do we know so far? We know that the voltage with the battery is 12. We know that the voltage here across resistor 4 is 3.8. So that tells me that everything in this circle here, that the voltage for that section of the circuit has to be 12 minus 3.8, right? Because that dotted section starts here and everything is in there until this point here. So 12 minus 3.8 equals 8.2 volts. Okay, so 8.2 volts is the pressure difference for this section. Now let's look at what's in that section. That section is two things in parallel, although this one was a combination of two resistors. So let's go back to this picture. So it's 8.2 volts for this whole section. Okay, but what we have there is two parallel branches, this branch and that branch. So each branch would have a pressure difference of 8.2 volts. This branch has only one resistor in it, so that means that this pressure difference is across that whole resistor. So 8.2 volts for resistor 3. And looks like I can find the current in resistor 3. That might be useful. Let's go ahead and find that. Resistor 3 is 90 ohms. So the current comes out to be okay. So if we know that the total current is 0.19 amps, and we know that 0.091 goes this way, then the rest of it must have gone that way. So that tells me that, well, what I'm really saying here is I'm saying that the total current, which is what we have over here, or the current through resistor 4, which is equal to this, it's going to be equal to the current that goes through 1 and 2 plus the current that goes through resistor 3. The same current flows through both of these because those are in series. So the current in this branch plus the current in that branch equals the total current before it split up. So the total current before it split up was 0.19 amps. And we know that in this branch, the current was 0.091. So that means 0.099, so about 0.1, rounding a little bit, is going to be the current in this branch. And once again, they have the same current because they're in series. So the current through the 30 ohm resistor is 0.1 amps. You could go on from here and complete the chart. I'll go ahead and put these in To complete the chart, then you could calculate the pressure difference, or also called the potential difference, across these resistors by multiplying the current times the resistance.